Hi, everybody. My name is Amir Shevat. I work in a company in San Francisco, so that means that in 1 minute it's going to be tomorrow for me in my time zone. So I woke up today at 4 in the morning. Oh my God! And by the time I finish my jet lag, I'm going to be on the way back. So that's the story of my life. I work as the VP of Engineering in Twitch. For those of you who don't know, Twitch is a streaming platform for shared experiences where people can go and stream their experiences from games to any type of experience and have an awesome experience, community experience there. Before that, I worked in small companies, which you might have used in the past. I worked at Slack, I worked at Google, and I worked at Microsoft. And I also sold one startup and crashed two. So that's pretty good for the Silicon Valley in terms of, thank you. Other things, so I don't really sleep much, and other things that I do in life is write books. So I wrote the design book last year, designing bots, so building conversational interface. How does software going to talk to us in the future? And in 2 months, I'm going to publish the next book, which is designing web APIs, building APIs that developers love. So coming soon to a theater near you. Today we're going to talk about, by the way, I just want to prefix everything that I say. I'm doing this from my own personal experience. I don't represent any company here. What I did in the last couple of weeks is talk to a lot of my friends who are using serverless in the Silicon Valley and ask them for what works and what doesn't. So what we're going to talk about today is a compilation of what works and what doesn't in real life. Does that make sense? I also have a deck about New Zealand, so every time, if it's boring at any moment, you can do like this, and I can show you a slide deck from my life in New Zealand. I lived there for 2 years. Okay, so let's get started. This is why I think serverless is awesome. How many of you use serverless here? Okay, awesome. For those of you who don't, serverless is an amazing deal. You give code, you get a URL. And now when you call that URL, that code is executed. So it's a pretty awesome deal. But if we look at the history of awesomeness, we had to deal with a lot of crap in our life, right? In the beginning, we had to manage everything. We had a pizza box, and when the server fell, it could be that the server physically crashed, right, on the floor. And we had to manage the hardware. And then came infrastructure as a service and took that poop away from our life. Right? And now we don't need to manage hardware. And then came platform as a service, and then we didn't need to manage the operating system and to patch it and to maintain it and to make sure that it's secure. Then now comes the functions as a service. And the idea here is that we only need to care about the code that we write. We don't need to care about the framework or the platform or any other aspect other than our code. It's asynchronous, it's event-based, so it's a new way to design software in a way that is highly scalable and highly orchestratable. So you can build amazing software that scales to infinite, and you don't have to deal with all that crap. Okay? Awesome? Perfect. So I'm going to talk about two big topics. One of them is major use cases, when to use serverless, and the other one is major misuse cases, which is when not to use serverless. And at the end, we can do a little bit of questions and answers. So let's start. At the end of the day, as we said, serverless is a very simple deal. You put in code, you get a function. So common functions that we've seen a lot in the Silicon Valley in the beginning of last year were batch services. I want to send emails. I have a database full of clients, and I want to send them an email doing retargeting campaigns. So I start a batch process, and that batch process starts to call the serverless functions. This is easy because now you can send millions of emails without needing to manage the server or server load, right? And because this is something that you can go in and batch on a night basis, you don't need a lot of like scalability that is not built into the function. So we'll talk a little bit about when functions work and when they don't, but serverless really works well for batch processes. So anytime you have a big chunk of compute that you can break into small functions, this is where this technology shines. Another use case that I really like is, when you say ETL, I don't know if you say you love ETLs, but as engineers, sometimes we need to do ETLs. For those of you who don't know what ETLs are, they're a way to move one data store into another data store through transformation. So I have tables in one database and I want to move them to another database and I need to transform that information into another form. Maybe I'm releasing a new version of my app which needs a different data structure in the database. Or maybe I need to export my data to a partner or something like that. So I need to take the information, do a little bit of transformation, and then send it to another source. So this is a very, very common use case for functions, because you can actually break things down into the components of the extract, transform, and load into the new data source, into the target. So as you can see, you pick up a row from the database, and then you can actually fan out to multiple functions. So depending on the row and the information, you can create multiple functions that deal with each transformation, which is usually kind of hard when you're writing a script and you need to do a lot of ifs. Now you can actually fan out to the right function. So I extract the information, and then I send it to the right function to do the transformation, and then I aggregate it back to loading into the database. So it's an easy use case that hasn't been very easy up until now. Okay, so we talked about ETL. Another thing that is really popular are fan-out cases. So the idea is that I have a function. The function decides what to do, but instead of doing it, it aggregates, it acts as a multiplexer into a second function. So I get a piece of information, and now I need to either break it into multiple compute functions, or I need to send it to multiple instances. So function A decides whether to send it just to function B or to all of them, or separate parts of that information into multiple functions. And then you have function C, which is the aggregator. The tip here, which is very important, is be very afraid of recursive function call. I have a friend, this is true story, who went through $10,000 of cloud compute by doing a recursion. Okay, true story. It happens, especially if you call yourself, right? So if a function, of course, can call itself, and I'm sure all of you are engineers here and know what happens when a function calls itself without a termination sequence. So when you do it with serverless, you can actually run out of money really fast. This is another, we talked about ETLs and batch functions. Another use case which is very common are the event handlers. So let's say we have an event of social information coming from Twitter, or we have a stream of information coming from the New York Stock Exchange. Okay, so we have a list of information coming in, and we need to process that information, do a little bit of compute on that information, and then store that information in a data store so that we could use that information later on. That's a very common use case, right? So with serverless, it's very easy to build that. You have event handlers that are functions that handle different events. They can easily scale out and scale back when there's more information. So when there's something on Twitter that is burning and everybody's talking about it, it could look for that hashtag and it could scale very easily, process that information, and store that information in data store. What's interesting here is that you can actually do multiple triggers. So when let's say an event comes, the function handles that information, puts it in a data store. The act of putting something in a data store could be a trigger for another function, right? So you can actually create workflows that are distinct and decoupled from each other, that are very useful in a way of understanding how you build your software. Because the developer that built the function that puts it into the data store is unaware, doesn't care about what happens after it's there. And just by triggering the other function, you can actually, sorry, I'm taking a photo here. Just by taking that function, you can actually decouple between the functions that are inbound and the functions that are taking care of the data. Okay, so event handling, everything from stock data to information from your servers, event, any type of event that you want to process and then store and act upon. This is one of my favorite use cases because I love APIs. If you want to build an API, a RESTful API for your service or for your product, you can actually use functions to do that. So the way you do it is that you define your RESTful endpoints as cloud functions. But remember, I give you code, you give me a URL. That's the deal, remember? But that URL could be very sucky. So it could be long and very hard. So if I build an API with multiple endpoints, one of them is going to be on one domain, the other one might be on another domain. So you have multiple URLs that are not very easy to digest as the developer on the other side. So what do? You put in a gateway that maps between your functions and the rest of the world. That gateway can map in from a URL, and I'll show you, here's the example. So in this example, I map between the routing template, what is the URL that the developer who's using the API is looking at, and what is the back-end function that I have. So you can actually build a lightweight layer of APIs using functions, and the developer doesn't need to know that you're using one function or the other. You can easily map and obfuscate that information and create a solid API using cloud functions. It's a very, very easy way because if you want to add another endpoint, you just configure another thing like that, put the function, and you have another endpoint. Cool. This is one of my favorites. As you can see, I love bots. How many of you have Alexa or Google Home or Slack bots? Yay, Slack bots. Awesome, thank you. So I love Slack bots. I worked on the Slack bot framework. So for those of you who don't know, Alexa is a service provided by Amazon. It's a bot that lives inside your kitchen or house, and you can talk to it. You can say, Alexa, what's the day? Oh, sorry, what is the day? That's pretty stupid. What's the weather? Or play me my favorite song. We live with Alexa. My kids love Alexa. We actually have Alexa and Google Home, and the kids debate who's nicer, who's smarter. They score it. But this is the future. The future is that we're going to have software talking to us all over the world. And software is going to be transparent. Software is going to be conversational. At least that's what I believe. And it's happening. So we have Alexa, and we also have Google Home, and there's the Slack bots. This is the most common use case for functions, or backends for bots. So when you say, hey, Alexa, what's the weather? The service powered behind that, if it's a third-party service, is probably powered by a serverless function. And the vast majority of functions behind Google Actions and Skills are powered by functions. Let's look a little bit about the architecture. So this is the first serverless function that I've built. It's more of a marketecture than an architecture. So this is my marketecture, which is a marketing architecture. And this is how it works. You say, hey, Alexa, I want to send, this is what the first function that I've ever built. This was 2.5 years ago. I wanted to send messages to my team at Slack when I'm late, when there's traffic, right? So I wrote a skill that lets my Alexa send messages to my Slack channel. So it works like this. Alexa, tell Slack, I will be late today. And that posts a message into the Slack channel. Okay, that's the functionality. It worked amazingly well until my kids found out that they could do it as well and start fucking up with my team sending random messages at different time in the day. And then I had to kill it. Soon they'll have voice recognition and they know that, and then I won. Okay, so how does it work? The Alexa bot that lives inside your house connects into the Alexa service. This is very important because a lot of people think that they have a direct connection between Alexa and their function. That's not true. So what happens is that there's an Alexa service that happens in the middle. What it does is transcribe your conversation, okay? So it takes what you asked and turns it into text. And then your function, your serverless function, gets that text. And then you can do whatever you want with it, and what you return as text is what Alexa says back to the user. Does that make sense? So there's a buffer that happens between the actual bot and your function. And what you can do on the function is two things. You can return a text that will be said to the user, and you can take action. So what I did is very simple. I send the Slack service a message to send a message into Slack, and I returned, hey, I just sent your message. Okay, so that was very, very simple. If we look at the code, even if you're not an engineer, you can see more or less what I'm doing here. I'm looking into the Slack service to make a call. I'm getting the text from the function, and then I run the web URL, and I either post the message or I have an error. Okay, so this is as simple. Creating this did not require me to install any server. There are people who love DevOps. I'm not one of them. Okay, so this was an awesome experience for me because I just had to provide this piece of code. So that was the magic that happened. So now we talked about the most active use cases. I want to talk about the misuses. It's very important as engineers to know when not to use a technology, right? Even sometimes more important, because once you go into a technology, getting out of it, it's very expensive. And I love to code. When my kids wake me up in the middle of the night, I code, but I don't like to code something that I need to throw away. That's a bummer. So let's talk about the misuse cases of serverless functionality. So the first one, this is for those of you who, I'm sorry, the reflection doesn't work really well. This is an ambulance, okay? For mission-critical services, I would not recommend using serverless. I just spent the last couple of hours between 4 and 6 in the morning reading through the SLAs of most of the serverless functions, and they do not provide 5 nines. The most I could find are 99.5, and it only talked about availability, not about execution time, right? So there's a thing called warm-up. So when a service function comes up, it takes it a little bit of time to warm up because it's actually run on a server. You don't have to worry about the server, but somebody needs to worry about that server. So that server needs to come up. Different functions provide different SLA and functionality, but if somebody will die because your code doesn't execute, don't run it on serverless, please, okay? That's the rule of thumb. If it's mission critical and somebody would die or you lose shitloads of money, I wouldn't recommend running it on serverless today. It might change, but right now I wouldn't recommend that. The other one, which is very important to know, is that serverless functionality provides some security and some authorization and authentication, but for some requirements, it does not fill all the requirements. So if you have a hybrid solution, some of it is on-premise, some of it is in the cloud, and you have distinct security requirements, your cloud provider might not meet all these requirements with serverless. So what do I mean? I'll give you an example. When I worked at Slack, we went to one of the providers and asked them that we want each server function, each function that we call, to run under a unique user and not to be able to call other services on our account, right? We wanted isolation. And at the time, I think even now, they couldn't provide that. So that was a simple requirement. We wanted an isolation sandbox for each type of function, and that was not met. So think really hard about what are your security requirements and what are your uptime requirements. And if you have a complex diagram like this, you need to think about is serverless function the right thing for you? Most serverless providers do not provide an on-premise in your office solution. So just know that. And now I need your help. Cool. The third one that I talked to a lot of developers, and they all mentioned that this is something that a lot of developers run into, is long-running functions. So if you have a piece of compute that will take a long time, and you can't break it into distinct, short-running functions, then serverless is not the right thing for you. If you have an Atom transaction that takes a long time, or certain compute functionality that requires a lot of time, your function will time out before it happens. And when it happens, it's really, really bad, because that's already after you've written the code, right? And it's when it hits real life, and you have different inputs, and your compute time becomes longer, that's when you start seeing the timeouts, and that's really sad. Another thing is that if you need to use dedicated hardware, so if you need to use a GPU in your calculation, at least from what I read all night, none of the serverless functionality from all of the providers today do not provide you with an ability to call the GPU. So if you have a kind of code that needs to run on GPU, let's say AI or some Bitcoin, awesome startup that you have, then serverless might not be the right solution for you. The last one I want to share not from my experience, but I've talked to a lot of companies, and this is one of the key non-technical, but more of a business misuse, is that if you have a project that has needs a lot of developers, it's still kind of hard to find developers who are very proficient in serverless. So if you have a project and you need 1,000 developers or even 100 developers, it's going to be kind of hard for you to find a lot of developers with experience. If a developer tells you that they have 5 years of serverless experience, they're freaking lying. It might be a requirement, and I've seen a requirement of 5 years serverless experience, but that's like, yeah, that's not going to happen. It's going to happen in 3 years. But you need to understand that if you're looking for a big project, you need to either train your developers or find a technology that is more commonly used. Yes, a question. So the question is it easier to be a serverless developer? So the question was, is it easier to be a serverless developer than a non-serverless developer? I would say for the short, small things, yes. For the batch processes, maybe. For building complex functionality, it's actually kind of hard. Because building scalable technologies is not easy. And building an architecture that is based on asynchronous event-based calls is hard and not intuitive. So as a developer, I know that I can call a function and it will automatically come back. But as a function developer, I need to call the function and then let it do its course. So it's a different mindset. I don't think it's easier, it's just different. And right now, there's not a lot of understanding today in the market about how to do that. This is the lessons learned. So use serverless functions to rapidly prototype and create scalable services to process inputs and to rapidly create web interfaces. It's the easiest way to handle batch processes, to run ETLs, to manage events, and to create APIs. But make sure that your requirements are met. This is very important. Whenever we use technology as engineers, we want to use this technology for everything. And that's a common mistake. Not everything could be solved by a bot. Not everything could be solved by blockchain, God forbid. And the same is true for serverless. Serverless is a great hammer. Most of you in 5 years are going to write in serverless functionality for sure. It's going to be delightful and awesome. But you'll know when to use it and when not to use it. Right? Just like AI and any other tool set that you'll have, you'll know what is the right nail that you need to hit with this new technology. Thank you very much. Yes. So the question is, when you scale out, you pay more for management, right? For management overhead and communication, right? That was the question. So the answer is yes, but what you get in return is infinitely scale. So if you need to tackle a lot of information, let's say in regular managing, moving a file from here to there, using regular code will be a function call, and you can have a server that goes back and forth and does that. And if you use serverless, you need 10 methods to do the same thing, right? So let's say you pay another 20% of overhead, right, for the management and transformation. But now you can do it multiple millions of times in parallel. So you win through parallelism, right? Do you understand? So for every function, you pay a little bit of overhead of management and communication, but what you get in return is running the same thing 1,000 times and not worrying about cost or management. So that's a trade-off. So I'm not saying there's no trade-off. If somebody tells you, hey, this is a technology that has no trade-offs, I would probably run away screaming. There's always a trade-off, but this is the trade-off that you have to pay. So the question is there a function where you, like it makes more sense not to use serverless? The answer is definitely yes. I would break it in the order of magnitude of the compute time that you are allowed by the serverless provider. So if your function is going to time out in 30 seconds, I would do a 15 seconds compute in order to make myself have a nice buffer there. Yeah, one more question. Last question. So the question is, when do you use spot instances and what do you use serverless? And the cost is an issue. So I agree, I had companies do this, like EC2 spot instances versus serverless. In some instances, it makes more sense. Sometimes you just need so many instances that it doesn't make sense to manage the spot instances, and you need to do that in a timely manner using functions. There's going to be someone here, one of my colleagues from AWS, and that's probably a great question for that person. So again, thank you very much. I'm out of time, but you've been awesome.